All right, hello everyone. I see that we have some questions in R.1 and R.2, so we're going to try to tackle those very quickly. In R.1, we had a few questions about numbers 13 and 17, dealing with sets. All right, so the universal set, which includes all the numbers in our set, in this case is 0 through 10, all of those integers. Number 13 asks us to find the union of A and B that intersects C. So union means all the elements that are in each set. So the union of A and B, if you look at each one of the sets, A has 1, 3, 4, 5, and 9. B has 2, 4, 6, 7, 8. So they have all the numbers through 9. Sorry about that, and that 10 shouldn't be there. So we want to find the intersection of those numbers with C. Well, if they have all the numbers in the universal set, the intersection of those would be all the numbers at C that are in C. Because 1 is in C and it's in A, 3 is in C and it's in A, 4 is in C and it's in A and B, and 6 is in C and it's in B. So the intersection of that would simply be all the elements that are in C. Now, number 17, it asks for the complement, that's what the bar means, of the intersection of A and B. That means that we're looking for the opposite of the intersection of A and B. Well, the only number that both A and B have in common is 4. So that's their intersection. So the opposite of that will be everything else in the universal set with the exception of 4. So that will be the complement of the intersection of A and B, just the opposite of what's in the universal set from what they're asking. Okay, R.2, number 65 says to determine the domain of the variable x. All the possible numbers that x could be, that's our domain. So it's easier in this case to determine what x could not be equal to. We have to keep in mind that anything divided by 0 is undefined. Therefore, any value that I could place in for x that would make my denominator equal 0 would not be valid for this particular problem, this particular expression. So the easy way to determine what the domain could not be equal to is to take your denominator, set it equal to 0, and solve. So add 5 to both sides. This tells me that if x was equal to 5, or if I replace x with 5, then I would have 5 minus 5, which is equal to 0. And we know that anything divided by 0 is undefined. Therefore, my domain could include all of the values of x such that x could not be equal to positive 5. So that's the only real number that x could not be equal to is positive 5. That's where our domain is asking for. Okay. Number 91 in R.2. We have this expression here. So if you need to rewrite it down, you can pause the video. That we need to simplify. Okay, so let's start off by simplifying negative 2 to the third power. Since the negative 2 is in parentheses, that means negative 2 times negative 2 times negative 2. And negative 2 times negative 2 times negative 2 is negative 8. Now x to the fourth is just x to the fourth. YZ to the second power with the exponent on the outside. That's kind of like using the distributive property with that exponent. So that's the same thing as y to the second power times z to the second power. Now in our denominator we have 3 to the second power, which is 3 times 3, or 9, x, y to the third. Now, since I have all multiplication in my numerator and all multiplication in my denominator, then I can simplify. Now, if I could simplify the fraction -8/9, if there was a number that would go into both of them, then I would simplify those numbers. But I can't, so I'm just going to leave that part as -8/9. However, I have x to the fourth in my numerator and x to the first in my denominator. Our quotient rule tells us to subtract exponents if we're dividing like bases. In other words, I have x times x times x times x in my numerator, that's x to the fourth, over x to the first. Well, I can cancel out one of those x's, and you see that that leaves me with x to the third power. With my y's, I have more y's in my denominator. So if I use my quotient rule, then I would end up with y to the first in my denominator, because 3 minus 2 is 1. Then my z's, I only had z to the second in my numerator, so it would stay where it is. Okay, and the final problem, number 95. It says if x equals 2 and y equals -1, find 2 times x times y to the negative first. Well, first of all, let's rewrite that to where y has a positive exponent. To make a base that has a negative exponent positive, then we move it. Right now, the y is in my numerator. So if I want to make this into a y to the positive first power, then I take the y and move it to my denominator, and that's understood to be to the first power. So when I move that base, it changes the sign of my exponent. Now I can substitute. So my problem told me to replace x with 2, so I would have 2 times 2 in my numerator, and to replace y with -1. Well, 2 times 2 is 4. And 4 divided by -1 is simply -4. Okay, I hope you found that to be helpful. Thanks.